Determine the derivative for each of the following. For part A, we have f of x equals e to the power of negative 5x. And we know from our formula sheet that we have a formula for differentiating exponentials with a base e. So when we want to differentiate e to the power of ax, we simply identify the coefficient of x, which is a, and the derivative will be equal to ae to the power of ax. So we simply multiply by the coefficient of x. So therefore, for this question, the derivative, which we can denote with f dashed of x, is going to equal negative 5, the coefficient of x, multiplying e to the power of negative 5x still. So unlike polynomial terms, we don't subtract one off the power here, which is a common mistake. So that is our answer to part A of this example. For part B, we're going to apply the same rule, and we're going to differentiate g of x is equal to negative 3 times e to the power of x over 2. So our derivative, g dashed of x for this question, is going to equal, and we look at the coefficient of x, which is a little bit more complicated this time. It's actually a half. So x over 2 is the same as a half times x. And then we're going to multiply that by negative 3e to the power of x over 2. And then just simplifying that slightly, we find that g dashed of x, our derivative, is equal to negative 3 over 2 times e to the power of x over 2. So that is our answer to part B of this example. For part C, we have h of x equals e to the power of 4x subtract 1. And our derivative formula still applies so long as the term in the power position is linear. So we still just look at the coefficient of x, which is 4 this time. So our derivative will be equal to 4, the coefficient of x, multiplying e to the power of 4x subtract 1. So that is the answer to part C of this question. And just to point out that the subtract 1 that's here isn't actually subtracting 1 as part of the differentiation process. Just a reminder that that's not taking place with this formula. That subtract 1 was always in our exponent or our power position. So our power remains the same here, and we just take the coefficient of x and multiply it out the front. So for part D, we have y equals 1 divided by e to the power of 4x subtract 3e to the power of 2x. And what we want to do here is we just want to express these as being in the form e to the power of ax. So for that first term, rather than 1 over e to the power of 4x, we can write this as y equals, and this would be the same as e to the power of 4x to the power of negative 1. That's another way of writing 1 over e to the power of 4x. And then we'd still have minus 3 times e to the power of 2x. So when we have something to the power of, and then we take all of that to the power again, we can simply multiply the two powers together. So we're just going to have minus 1 times 4x in our next line. So therefore, y can be simply written as e to the power of negative 4x minus 3e to the power of 2x. So we can now calculate the derivative dy dx, which is what we were asked to calculate for this question. And using our rule, this is simply going to be minus 4 times e to the negative 4x. And then we're going to have minus 6 when we take the coefficient of 2 and multiply this term by the 2. So we'll have minus 6e to the power of 2x. So that is the answer to part D of this example.